Okay, so I'm just going to be wrapping up on a few things here. One of the concepts we've talked about before, just to remind you, is we'll be regularly making a decision. Do we program something or do we get a package or a library that does it for us? And this is something you'll have to decide on a regular basis. I highly recommend whenever you're looking at a complex task that you need to do, look to see is there an existing package that will do it for you, an existing library for Python that will do it for you. And look at it. Not only look at the documentation, look at the website, but check the blogs, ask people, see how well it works. There are thousands of packages out there, lots of open source code available. Most of it is not very good, and you can get stopped in a number of ways using packages. The quality of the package and if it does what you need is of course the number one, but also just the documentation. If you can't get through the documentation and figure out how to use it, then you can't use it. Is there support? If there isn't good documentation, maybe you can get a hold of the people who wrote it and ask them questions. And sometimes we can get past problems with that. But in the end, if you can't get it to work, or in some cases, if it takes longer to get it to work than it would to write it, well, that's when you program, write it yourself. And don't feel like that's something you can't do. You can always figure out how to write code, how to do something, because someone else wrote all the packages that are out there, including Python itself. So these are all developed by programmers like yourself. So don't feel like you can't do it. It's just a matter of which makes the most sense for your time and what you want to focus on. Moving on, there's a number of other classes out there that I would recommend. GSP 470/570 spatial modeling is largely done in R. So having a programming class behind you will help. There, R is another programming language. It's scripted like Python. It's just specifically for doing statistics. I teach a 418 class in the fall of Programming 2, and that's going to be, 2020, working with JavaScript and putting cool maps on the web. CS 325, taught by Sharon Tuttle in computer science, is a database design class, and then she has a follow-on to that for building web-based applications using PHP. If those have programming prerequisites, but you can get a permission number from her because she takes this class as a prereq. And then go out on the web. Most of what I learn now is off of W3 Schools, and there's a bunch of other great websites. Great information on the web. It's rare that I pick up a programming book anymore. Once in a while I do, but almost always I'm just learning off of the web. And of course, accessing materials from other folks and talking to other folks about what to do. Now, the world you're stepping into is big, very different from when I started programming. We just had workstations when I started programming, but now we've got big server farms out there with huge amounts of data, it's satellite data coming down to it. There's sensors out there. You can build your own sensors and use dedicated controllers like Arduino or Raspberry Pi to build your own sensors in the field and collect data. You could then have those coming back into the internet, and you can pick up that data remotely. And then, of course, you got mobile devices, and this is a big trend, as you're aware. I have a little Pokemon on there because I think it's Pokemon Go or something. It was a big craze a couple of years ago. And that allows your mobile device to connect into this huge system. And that's one of the biggest things that's happening is that all these different devices are being integrated together in what's being called the Internet of Things. And it's an incredible, world. And I remember traveling with a friend of mine through Denver, and she said, "Well, look at my iPhone, to see if the traffic is good to go through 470 or I-25." And I was like, "What?" And sure enough, her phone had this app on it, which is now commonplace, that showed red on I-25 going through Denver, so we took 470. But that made me think about, here's this phone that has to go through a phone network to then go to servers that are managed by the state that then have all kinds of sensors scattered across the freeway system to detect traffic flow. Just this incredible network that's out there, and we expect to see that grow. Now, there are two different types of languages, scripted and compiled. Python is a scripted language where each line of code is parsed and then executed. These are typically fast to write but slower to execute than compiled. Great for things like data acquisition, preparing data, a lot of other things. Now, Python is actually compiled, and you'll see these PYC files appear, or a Python cache folder start to appear next to your Python files. That's a compiled version of your Python scripts. And if you edit the Python script, those will then be updated automatically by the Python interpreter. Now, those are faster than doing each line of code and execute it, okay, which is more traditional with an interpreted language. So it speeds up Python quite a bit. It's still not as fast as most compiled languages. With a compiled language, the program is compiled, so there's source code, like with Python, and then it's compiled into, we call machine code, so code that the computer can read directly, and then it's executed. All of our programs like Microsoft Word, Excel, Wing, PowerPoint, the Windows operating system or Unix operating system itself, those are all compiled programs. That's slower to write, takes more time to write them, but then faster to execute. So again, this is one of these trade-offs. These are best where speed is needed. So if you get into a problem with speed, especially large data prep or simulations, you'll want to move to a compiled language. Now, there's also a lot of different applications that have scripting built into them. Excel has what's called Visual Basic for applications. I'll talk a little bit more about that because it's very powerful. R, SPSS, and SAS. SPSS and SAS aren't used as often as they were. R is pretty much taken over the statistical world. ArcGIS, of course, has Python that you can script it with. QGIS has Python you can do internally, but it's harder to do it externally. Blue Spray, you can do either with Python or JavaScript. MATLAB, Logo, Stella, there's lots of them out there. Okay, so a few to highlight: VBL, VBA in Excel. This is the easiest way to prep data in Excel. If you have data in Excel, if you work for an organization, process a lot of data in Excel, VBA is a great environment. It's built into Excel. It's got a nice IDE. You can build GUIs inside of Excel. Lots of documentation available for it, and you can even provide forms for people to enter data so that the data is of higher accuracy. Python, of course, we just spent a lot of time on, and you can interface to just about everything. That's the other benefit of Python, besides its flexibility with all the libraries that are out there, is it can interface to anything, including R, SciPy, a lot of other programming languages, and does it relatively easy compared to most languages. R, again, is really a vector and matrix-based statistics package. In other words, you can have matrices and vectors, large matrices of numbers, and add them together with one line of code. PHP was very popular for server-side scripting. It's not as much. Python is starting to take over from that. And there's a lot of other languages used for server-side scripting. In other words, that's where you have your client, like your workstation or your phone, talking to a server, and then the server is running code in the background. JavaScript's also being used on server side. I should mention that because Google largely uses that. So in Excel, you can go to things like File and customize your ribbon, and then under Customize your ribbon, you'll see Developer, and that'll bring up a Developer tab where you can then get into the integrated development environments built into VBA and Excel. And it's got good debugging tools, and again, graphical interface. Here's a shot of what it looks like. Allows you to have these sheets, allows you to write code. It also has a really good GUI builder. I like it a lot. I kind of miss working in it because it is a really nice system. Compiled languages, Visual Basic is Windows only, so it's pretty cool, but limited because it's Windows only, and it's really only being used heavily where it's built into these applications, but it is a separate language as well. Visual Studio is very powerful, expensive, complex development environment that's put out by Microsoft. I worked under it for years. You spend a lot of time just configuring it and getting it to work properly. Visual Studio Code is a new free one that's actually available from Microsoft, both for Windows and for Mac, which was kind of surprising. I think it also runs on Linux, and it's pretty nice. In fact, I almost used it for this class, but Wing is specifically for Python, so it takes a little bit less setup. But I like Visual Studio Code. And Visual Basic is also relatively easy to write. So Java, oh, and I should have mentioned VB is the compiled version of VBA. VBA is Visual Basic for Applications. VB is Visual Basic, and it is a compiled language, so a little different. Java is my favorite compiled language. It's portable, Windows, Mac, Unix, relatively easy to write compared to like C++, and it's free. It's open source. It's part of the open source community, so there's a couple hurdles there as far as who's going to manage it. Oracle has managed it for a long time, I believe. Sun originated it, so that's the only issue I see with Java. And it has some security uh, issues around it, but they really were blown out of proportion in a war between Microsoft and Sun um, that caused us to have all these different compiled languages instead of one great one. And Microsoft's response to that was C Sharp. And so it's another language, Windows only, of course, similar to Java. I like Java better, but that may be personal preference. A lot of people are still writing C++. I don't know why. I wrote C++ for a long time, and it's harder to write than any of these languages. And worse, you can have defects in it that are extremely difficult to find. In other words, in Python or just any other language, if you have an array that has 10 elements in it and you write to the 20th element, every other language on the planet now, I believe, will give you an error. C++ will not. It will just put data into memory where it shouldn't, and that can overwrite other data. It can overwrite your code. It can cause all kinds of problems, and it may not show a problem until a year down the road, and all of a sudden your program is crashing. You don't know why. So that's one of the challenges with C++. Most people then wrap all their memory allocation, their array handling into another class, which slows it down a little bit, but definitely worth the investment in the long run. Fortran is out there. Some people are still using it, as are languages like COBOL and things like that, but those are languages, in my opinion, that are going away. If you take a look at the statistics on the web, use those to guide where you want to put your time and effort for your career. Coming back to this, one of the issues here is that these different systems can be using different languages. The web and the REST protocols that we've looked at for communicating between them are kind of nice because they're language independent, so you don't have to worry about that. It's one of the reasons I don't use SOAP, because that specifically was built for Java, and it's pretty cool because you can have Java applications on different computers. They can talk to each other, but it's a very slow interface, and it really is Java specific. People try to use it with other languages, but I don't recommend that. I recommend using simple SOAP-based or REST-based protocols, just HTTP, request response. It's very fast, relatively easy, language independent. All right, so programming languages also tend to be dedicated again to one of these specific areas: servers, PHP, Python, C++, Sharp, Java. Those are the ones they use. So it's more flexible because it's a server. Similar on workstations, you have all these different languages, and I put SQL in there, structured query language. That's a database language. It's the most commonly used. That can also be run on servers. When we get down to the other categories is where you start to get much more limited. So mobile phones, or mobile devices, Android uses Java. That's it. It's the only choice you have, I believe. So you have to learn Java. In fact, you have to work within the Android environment to do that. Apple's mobile products use Xcode. It's a different language, and you have to develop in different languages for those different devices, which is a challenge. You have to have twice the programming resources that you need. Now, there are web browsers on all those devices, of course, so you can do stuff in JavaScript, but it would run inside a browser, which is great if that's your only alternative. But for products people use a lot, they're going to want to use a dedicated application. Now, a lot of folks go with Apple because they get so much publicity, but watch the usage numbers, and especially who your customers or the people who are going to be using your product are going to use, because Android is more popular. Sensors, Python, C++ are the most common. There's other languages out there, and you want to decide which way to go, because either way you go, Arduino or Raspberry Pi or another sensor, it's going to have its languages that it supports. Browsers, HTML, CSS, and JavaScript. That's it. That's all we got. That's all it's built in. HTML is a document format language. CSS is the style that gives you the fonts and the colors. and then JavaScript is a programming language. So it's kind of nice because you only have one language, so we don't have to learn multiple. And just to finish, I've mentioned this before, the biggest issue with Python is the libraries. There's tons of them out there. There's lots of problems with configuration as well as with the quality. ArcPy is, of course, that if you have Esri's products, it's slow, but it has tons of functions. It's very comprehensive. And it looks like with ArcGIS Pro, we're going to be able to get to other libraries. So that opens things up there. QGIS API, it does exist. It's just really hard to use. Blue Spray, you can actually talk to it from Python, but limited features, documentation, and testing. Because I really see it now as an application to fill in the gaps from these other products, not as a comprehensive GIS package. GeoPandas does bring together some of the geospatial open source libraries, but it's limited in what it can do, and it's harder to interface to than ArcPy. So that's why we've built SpatialPy, and we'll see what happens there. It's still in early development. If you want to help with it, let me know. I'm going to try and make it be easy and fast and free, the ultimate GIS library, but the jury's still out on that. All right, have a great time and look forward to working with you in the future.